The sky went dark at 3 in the afternoon. Not an eclipse, not a storm. The sun simply went out, like a candle snuffed by invisible cosmic fingers. Temperatures already dropped 2 degrees in the last hour, and you feel the cold creeping across your skin as you stare at that black disk where the source of all known life once burned. 8 minutes ago, the light touching your face traveled 93 million miles. And now? Now there's only darkness. How long can Earth survive without its heart of fire? Nobody noticed in the first few seconds. The sun didn't explode. There was no dramatic flash, no shockwave rippling through the solar system. It simply ceased its nuclear reactions. 4.6 billion years of hydrogen fusion interrupted like a heart-stopping mid-beat. But here on Earth, 8 minutes and 20 seconds of delay separate reality from disaster. For one brief moment, you still feel the warmth of a star that no longer exists. And then the darkness arrives. Not gradually, like a sunset, instantly. The world plunges into permanent night, and panic spreads faster than any news report can explain. Streets light up with car headlights and phone flashlights. But that artificial glow seems so fragile now, so pathetic against the vastness of the void that swallowed our star. The first hour feels strangely calm if you're indoors. Ambient temperature still holds that familiar comfort. Your heater works. Your food's still warm. Feels like nothing changed except that sky out there. But scientists already know the truth. They're already crunching the numbers nobody wants to hear. Earth's average surface temperature sits around 59 degrees Fahrenheit. Without solar radiation, that number starts plummeting. Within the first week, it'll hit freezing. By the first month, minus 40. Within a year, if anyone's still counting, the planet's surface will reach minus 100 degrees Fahrenheit, colder than any Antarctic winter, colder than anywhere humans have ever survived outdoors. But the cold is just the beginning of this nightmare. Photosynthesis stops immediately. Every plant, every algae cell, every organism that depends on sunlight to produce energy just shuts down. The oceans, which absorb so much of the sun's heat, begin freezing from the surface. First, a thin layer of ice, then meters thick, then tens of meters. Within a few years, the seas will transform into solid blocks down to a depth of miles. Here's something most people don't consider. Earth's orbit doesn't change. If the sun simply turned off but kept its mass, we'd keep orbiting. But if it vanished completely, Earth would fly off in a straight line through interstellar space, like a rock released from a cosmic slingshot at 18 miles per second. Let's assume the mass remains, though, that only the light and heat ceased. That gives us time. Time to understand. Time to try surviving. On the second night, because every hour is night now, the stars have never looked so bright. Without the sun's competition, the Milky Way reveals itself in full glory. Billions of points of frozen light, beautiful, distant, completely useless for keeping us warm. You look up and realize, maybe for the first time, how dependent we were on a single star among hundreds of billions. 3 weeks after solar blackout, surface cities stand abandoned, not by choice, by pure, brutal survival necessity. Outside temperature has plunged past minus 22 Fahrenheit. Electrical grids collapsed in cascades, first in colder regions, then everywhere. Nuclear plants still function, but distribution infrastructure froze, literally. Power lines snapped like dry twigs. Transformers exploded under thermal stress. Modern civilization, built on the assumption of an eternal sun, showed its cracks. But humans are stubborn, irritatingly, magnificently stubborn. Mines became the new homes. Not for any post-apocalyptic romanticism, but simple physics. For every 100 feet you descend into Earth's crust, temperature rises about 1 degree Fahrenheit. Geothermal heat, residual energy from the planet's formation 4.5 billion years ago, plus radioactive element decay, keeps flowing regardless of the sun. Always has. Will for billions of years more. Coal mines in West Virginia, subway tunnels in Tokyo, natural caverns in Kentucky. Any hole deep enough became a desperate refuge. Humanity, which spent millennia building skyscrapers to touch the sky, now digs frantically to escape it. Icelanders and New Zealanders had a slight advantage. Geothermally active regions, where magma flows closer to the surface, offer accessible heat. Hot springs that were once tourist attractions became the difference between life and death. And food? Here's where things get truly grim. Global grain stockpiles last roughly 90 days under normal circumstances. With no replenishment possible, no agriculture functioning, no light for conventional greenhouses, those 90 days become a merciless clock. Some communities improvise hydroponic farms powered by nuclear or geothermal energy. LED lights replacing the sun. It's possible, but at a ridiculously small scale compared to 8 billion hungry mouths. The math is cruel. The vast majority won't survive the first year. But some will survive. Does that matter? Maybe. Nuclear submarines can remain operational for decades. Antarctic research stations, ironically already adapted for prolonged darkness and extreme cold, become survival models. Paranoid billionaire bunkers, once the butt of jokes, now seem like reasonable investments. Here's a disturbing thought. The oceans won't freeze completely. Beneath miles of ice, hydrothermal vents on the seafloor will keep spewing superheated water. Entire ecosystems exist around these vents, tube worms, shrimp, bacteria, completely independent of sunlight. They won't even notice the sun died. For them, nothing changed. Earth doesn't die. The surface biosphere dies. Humans, most humans, die. But life, that persistent and creative thing, will find a way. It always does. Deep in a copper mine in Chile, a child born 3 months after the blackout will never see the sun, never feel its natural light on her face. For her, stories about daytime will be as mythological as dragons are to us. She'll grow up knowing only the amber glow of geothermal lamps and the hum of recycled air systems. 100 years later, the descendants would barely recognize the old photographs. Not physically, though generations in low light would certainly alter some traits, but psychologically, culturally. The humanity emerging from bunkers and mines is a different species in everything except DNA. The sun became an abstract concept, like dinosaurs or the Big Bang. Real, sure, but impossible to truly comprehend. Geothermal colonies stabilized, few and scattered, maybe a few 100,000 people total, a statistical rounding error compared to the billions before. But alive, functioning, even developing something resembling culture, art, music. Songs about the sun comprise an entire genre now, hymns of longing for something the singers never experienced. The surface, meanwhile, transformed into something alien. The atmosphere didn't disappear, it partially froze. Nitrogen snow blankets what used to be rainforests. Oxygen exists as scattered frost in the deepest valleys. Only Earth's rotational momentum and core heat prevent the entire atmosphere from becoming a frozen shell. Walking outside without a pressure suit would kill you faster than the cold would. Your lungs would burn from the thin, frigid mix of whatever gases remain gaseous at -300 Fahrenheit. But here's what makes this scenario so strange. Earth wouldn't be alone in its journey. Without the sun's gravitational anchor, assuming it vanished entirely, our planet would drift through interstellar space, carrying its frozen oceans and burrowed survivors. The moon would tag along, still faithfully orbiting, a tiny two-body system hurtling through the galaxy at tremendous speed, passing other star systems over millions of years. Could we reach another star eventually? Theoretically. The nearest, Proxima Centauri, sits about 4.24 light-years away. At Earth's ejection velocity of roughly 18 miles per second, we'd arrive in approximately 50,000 years. Not exactly a practical rescue timeline, but not impossible either for a species that learned to survive on geothermal heat and recycled everything. The philosophical implications might matter more than the physical ones. We've always defined ourselves by daylight. Our circadian rhythms, our religions, our metaphors, all anchored to that burning ball in the sky. Bright means good. Dark means evil. Dawn represents hope. What happens to human psychology when those references lose all meaning? When generations grow up knowing only artificial light and geological warmth? Maybe they'd find new metaphors. The deep earth becomes mother. Heat rising from below becomes sacred. The concept of looking up for salvation inverts entirely. You look down now toward the core, toward the warmth that sustains. Scientists in 2024 actually model these scenarios, not because they expect the sun to die. It won't for another 5 billion years, but because understanding extremes teaches us about our dependencies, our fragility, our surprising resilience, and that might be the real lesson here. We imagine ourselves as masters of this planet, builders of cities, conquerors of nature, but strip away one star's light, and we're reduced to mole people scratching for warmth in the dark. Everything we've built, every monument and highway and glittering skyline, becomes a frozen museum within months. Yet some of us would make it. That's the stubborn truth. Humans survived ice ages with stone tools. We'd survive a sunless Earth with nuclear reactors and sheer bloody-minded determination. Diminished, changed, but not extinct. The sun could die tomorrow, and 1,000 years from now, someone would still be telling stories about it. That's either deeply comforting or profoundly terrifying, maybe both.